shear, a force which tends to slide the material on one side of the surface relative to the material on the other side of the surface in the direction parallel to the surface is termed as shear. If we have two surfaces like this, one above the other, and we apply a force over here, a resistive force over here, so this force will try to slide this upper surface over the lower surface. So this type of force is termed as shear force, and the resistance between these two surfaces will be termed as shear resistance. If there is no resistance between these two surfaces, so we can easily move the upper surface over the lower surface. We can slide this upper surface over the lower surface. So here we have a demonstration. If we take two books, and in one book we punch holes and insert bolts to restrict the movement between the pages, and in the second case we do not provide any bolt and the pages are free to slide over each other. In that case, if we support these books at the ends like this, at here and here, and we apply force at this corner. So in first case, where we have provided the bolts, under the application of load there will be no slide between the pages. But here in the second case, just with the small force, the pages will slide over each other and they will move relative to each other. So here we have shear resistance, but here in this case we do not have shear resistance, and the force that we have applied have caused the sliding between the pages. So this type of force is termed as shear force, and the resistance provided by these bolts is the shear resistance. So next, how this shear resistance affect the flexural stiffness of beam. So for example, for the previous model, the model of book, in one case we have inserted the bolt to improve the shear resistance, and in the second case we have not inserted the bolts and the shear resistance between the pages is almost zero. And if we consider it as a beam and apply the load, in the first case when we have inserted the bolts, there will be very small deflection. So this is because this shear resistance have improved the flexural capacity of the beam. But in the second case, where these pages are free to slide over each other, the stiffness of the beam will be significantly less, and as a result the beam will deflect. We can also see some other model. Here we have two wooden plates, and if we place it one over the other and try to bend, so we can bend it easily. So excessive bending just with the help of hand. But if we join these two plates with the help of bolts and we restrict their movement relative to each other, so in that case if we try to bend, so it will not be possible to bend it, or there will be very small bending in that case. So this is because by providing the shear resistance between the two surfaces, the stiffness of the section or the stiffness of the beam will significantly improve. Okay, where we can use this concept of shear resistance. If we want to strengthen our beam with the help of steel plates, and we need to add multiple plates, and if we do not add the shear stiffeners or the bolts to hold these plates together and to provide the shear resistance between these plates, then the stiffness of the beam will not improve significantly. But if we add these bolts between these plates, the shear resistance between these plates will increase significantly, and as a result the stiffness of the beam will increase, and we can increase its flexural strength. In the second case, we have a shock absorber of vehicles. So in that case we do not provide the bolts between the plates. This is because in case of shock absorber, we need to limit the flexural stiffness of the beam to accommodate the shocks, to absorb the shocks. If we provide bolts over here, so in that case the stiffness of this shock absorber will increase significantly, and the purpose for which it is designed, it will not be fulfilled.